Alright, so in this video we will identify the vertex, the axis of symmetry, the max or min, the domain, and the range of our quadratic function. We will do this without using a calculator since on Thursday we will be having a quiz and we will not be able to use a calculator. So the first thing when we look at this quadratic, we can recognize a couple of things about this quadratic. The first thing is that let's look at the standard form. I'll write that above in a different color. The standard form of a quadratic is y equals ax squared plus bx plus c. Now that a value tells us something. We know if there's a negative a value, so if we have a negative a, the parabola will be an upside down u. And if we have a positive a, we know the parabola will be a u. So in our quadratic, we see a positive a. So we know that our quadratic will be a u. We also know, since it's a u, there has to be a minimum. I'll draw a dot like that, and there has to be a min. Now we know there's no max. Why? Because our function goes on forever. I could put little arrows here, and it goes on forever in the positive infinity direction in our y-axis, so there can never be a max. But there is a min. There is a minimum point to our function. So before we even start, we know that there's a min, and we know that our function will look like a u. Now let's find our vertex. And how we find our vertex is with the equation x equals negative b over 2a. Alright? We know our b is negative 4, so we always substitute in our numbers using parentheses. So we have a negative, and now let's substitute that b in. Negative 4. We keep that negative attached to the 4 because that's our b value. We divide the whole thing by 2, and we substitute in our a, which we can see is 1. A negative outside the parentheses makes the negative 4 a positive 4, because a negative 1 times a negative 4 is a positive 4, and that is divided by 2. So we see that our x-coordinate of our vertex is 2. So we could write that. So we could say vertex sub x equals 2. Now that we know that our x-coordinate of the vertex is 2, we could find our y-coordinate by plugging it in. So let's write plug in x. Plug in x. Right? And we get that y equals, you know what? I'll write the quadratic so you can see exactly what we are doing. Minus 4x plus 6. Now we can substitute in that x coordinate. So we get y equals parentheses 2 squared minus 4 parentheses 2 plus 6. And we get y equals 2 times 2 is 4 minus negative 4 times 2 is negative 8 plus 6. Alright. Let's put all the positive numbers together. We get 4 plus 6, which is 10. So we get 10 minus 8. And we see that y equals 2. So our vertex y, so we put vertex sub y equals 2. So we can say that our vertex, we'll write that in green, we'll put it here, make it nice and big. Say our vertex is 2, 2. Okay, now since we know our vertex, let's graph it. We can graph it right here. So I have my x and y coordinate, x and y axes. We can put 1, 2, and 1, 2. Make a dot. Oops, sorry about that. Make a dot. And we know that the parabola has to look like a U. So we'll make our U going up that way, and our u going up that way. Again, this is just a rough sketch. I'll put arrows on these lines. Now, most of the time you don't see arrows on the lines, but we'll put arrows just to remind you that those lines travel forever, going up and also out. So that goes on forever. I'll make my min point. As we can see right here, we can see that we have a minimum at this point, and we know that that point is 2, 2. That is our vertex. Alright, so the next question says, what is our axis of symmetry? Well, when we look at this function, we can see that it's symmetrical if we have a line, if we put a line right here. So I'll draw that line right here. So we're going to come down, and we'll draw the line, and it's a nice vertical line which we can fold our function up, and whatever's on the right hand side will equal the left hand side, whatever's on the left hand side will equal the right hand side. It will look the same. It's like looking in a mirror. And we can see that that line is right at our x coordinate of our vertex. So that line is x equals 2. Alright? So I could write that now. So let me just box in my vertex. We could box in all of our answers. So there's one answer. I'll put the line of symmetry now here. So we'll put line or axes. So I could put line or axis of symmetry. And that is x equals 2. And we'll box that in. Okay. Now, like we said, we have a min. We have a min because we have a u. There is no maximum. The lines go on forever, but there is a minimum point. So we can say that our min is at 2, 2, which is our vertex. And we'll box that in. We'll also say no max. We'll put a star, and we'll say no max. And we'll underline it. Okay. Alright, the next thing says we will need to find the domain and the range. Well, we'll put domain first. The domain is all x values of the function. So we could say all x values of the function. So when we look at our function that we just graphed, what are all the x values that make up this function? Well, we can see that this parabola stretches out both vertically and horizontally. So if it stretches out horizontally towards positive and negative infinity, it's going to include all the x values of our axes. So we can say that the domain is from negative infinity in the x direction, negative infinity, to positive infinity. And we can circle, we can box that answer. And now the range. So we have the range. Now what does the range mean? Well, the range is all the y values. So the range, we can say all y values of the function. Okay. Now when we look at our function, let's see the y values that make up the function. Well, if we look at the y values, I'll put it in a different color so you can see. If we look at these y values right here, are these values part of the function at all? If we were to make a dotted line, would they hit the function at all? And the answer would be no. They would go, we would have a dotted line forever, and it would never intersect our function. So the only y values that would intersect our section would start right here. This is our first y value that would intersect our section, and that intersect our function, and that is at y equals 2. Any y value above that, I'll put that in a different color so we can see. Let me choose, here's a good color. Any y value above that, any of these, would intersect our function. And those points would go on forever and ever. So the first point to intersect our section would be the low end of our range, and all the yellow hash marks, which would go on forever, would be our high end of our range. So what is that exactly? Well, we can see that the low end is our y-coordinate of the vertex. So the vertex was at 2, 2, which means y would equal 2, and we want to include that point. So to show that we include that point, we would have a bracket. So our low end of our range is 2, which is always on the left-hand side of our interval notation, and the right-hand side is our upper bound, or the highest possible y value. But we said before that this function goes on forever vertically. So our high-end value would be positive infinity. So our range is 2 to positive infinity. And remember, we are including that 2. And that's how you find the vertex, the axis of symmetry, the max or the min, the domain, and the range of a quadratic function. Alright, so we'll try another example. Again, we're going to try to find the vertex, the axis of symmetry, the max or the min, the domain, and the range of this now quadratic function. First thing we want to do is let's write our standard form, just so that we know where our a's are, our b's, and our c's. So it's ax squared plus bx plus c. And we can even label what everything is, so we can say that over here, we can say that our a is equal to -1, our b is equal to -3, and our c is equal to 6. So now that we know that, let's find our vertex. Our vertex is always at x equals -b over 2a. So we see that it's a negative. We then substitute in a parentheses -3 divided by 2 times a parentheses again to substitute in that a, and our a is -1. So we get a -1 times -3, which is a +3, divided by 2 times -1, which is a -2. So our x-coordinate of the vertex is equal to -3/2, or we can say -1.5. Alright, to find the y, we plug in. So again, I'll say plug in x. And we get, first I'll write the quadratic again so we could find it right under -x squared minus 3x plus 6. And now let's substitute in that x value. So we get y equals, again, I'm substituting in, so it's a negative, substitute in to, it's a -3/2 squared. Make sure you do that. It's a negative, then substitute in that x value. Minus 3 parentheses -3/2, and then plus 6. Okay, over here we get y equals, okay, we'll square the -3/2, so we get negative still outside, but when we square the 3/2, we get 9/4, because a -3/2 times the -3/2 is a positive 9/4, minus a -3 and a -3, so we can change this to a plus 9/2, and then we have plus 6. Now I put that 6 up on top because we know we're going to put that 6 over a 1. And that's why I write the 6 higher. We then have to have a common denominator. So we get y. We're going to choose our common denominator to be 4. And we're going to have a nice big line because we have 3 numbers to put up there. We can see we keep that -9 plus, we have to say 2 goes into 4 twice, so it's 2 times now 9, and 1 goes into 4, and now it's 4 times 6 now. Okay? We then get that y equals -9, again, whole thing over 4, plus 18 plus 24. So we see that y must equal then 18 plus 24 is 42, and then we have 42 minus that 9, which is 33. So y equals 33 over 4. Now we can also say that this is equal to, we can say that this is equal to 8.25. So I'll write the vertex in two different ways. We can say that the vertex then, I'll write it big, vertex, it equals -3/2, comma, 33 over 4, or we can say that the vertex is equal to -1/2, comma, 8.25. Whichever way you like is fine. And I'll box that answer in. Alright, now let's graph it. Alright, so this graph again is going to have, we draw our x and our y coordinates. Let's put our vertex in. We know our vertex is now going to be to the left, so it's 1. I'll make it y 2, 3. And we know we're going to -1/2, so I'll make a little mark right there. There's our x coordinate of the vertex. And now we're going up, so it's 1, 2, 3. Actually, you know what? Let me make them a little bit smaller. So it's 1, 2, 3, 4, 5, 6. Make it a little higher. 7, 8, and 9. Alright, our y coordinate is right there. And we can make a point at our vertex, which would be right here. There's our vertex. When we draw our parabola, it's now going to go down. You know what? Let me put in a different color so you can see it. Put it in red. Again, I'll draw arrows to remind you that it goes on forever. And now, why did I draw that as an upside down U? Well, we look over here, I'm going to box it in. The a minus 1, when we have a negative a value, that means that that parabola must have been reflected. Alright, so that means it's an upside down U. Now, the important thing to remember when we have an upside down U is our vertex point. Our vertex point right there. Now we see that there is not a min, because the minimum means what's our lowest value, and we don't have a lowest value. That our function goes on forever, both downward, vertically, and horizontally. So the only thing we have is a max now. So we can say that our max is at our vertex. And we can say that the max has to be at -1/2 over, -1/2, comma, 8.25. That is our max. That's our maximum height or maximum point of our function. And since we have an upside down U, there has to be a max. And now I could say star, no min. No min. Underline it again like I did in the other problem. Alright, now for our axis of symmetry. So where is our axis of symmetry? Axis of symmetry. Well, where is this function symmetric? Well, we can see again, it's going to be a vertical line. And it's the vertical line in the middle. And the middle point of our function is always the x-coordinate of our vertex. So the x-coordinate of our vertex is at right here. I'll say x equal negative 1.5. So we say the axis of symmetry is at x equals negative 1.5. Okay. Again, the domain, all the x values of our function, and we can see again, this function goes on forever, so our domain is still negative infinity to infinity. And lastly, our range. Range, we said, all the y values. So we look at our function. Where is the max y value? We said right here, at our vertex, our max y value, right here. Anything above that, we'll put in a different color. We'll put that yellow color we used before. Anything above here never touches our function. Therefore, it's not included in our function. That y value is not included. However, all the y values below our orange line are included. So we can say that our highest bound, our highest y value is 8.25. So we can put that on the right hand side of our interval. We could say 8.25. Now remember, I used a bracket because we want to include that point. That point is our vertex. We want to include it. Our lowest number of this function vertically is negative infinity. It never ends. So we never have a low point. So we have a negative infinity, and we can't include negative infinity because it never ends. So it's a parentheses, and we can box that in. I'll write down here so we remember. This is our lowest number, and this is our highest number. Just so that we remember. Or low bound and high bound. So here are the answers for your homework questions. 28 and 29 did have fractions, so hopefully you were able to figure out those answers without using the calculator. We have to get a little bit better with adding and subtracting fractions. So hopefully this gave you a little bit of a practice.